This question is about energy transfers. It says the diagram shows typical values for percentage energy losses from a house. So we can see that most of it is lost from the walls, and a very, very close amount is lost from the roof. Quite a small amount is lost by the windows, the doors, and through the floor. So the first question says, well, asks us which is the one that gives out the most energy, and of course we've already done that analysis in reading the question carefully. So we can answer that the roof loses the most energy. The total percentage energy loss from the roof and the windows is, so here we've just got to take 30% for the roof, 10% for the windows, and add the two together. So 30 plus 10 is going to give you the 40%, which is D. Part C says that insulation is used to reduce energy losses from houses. Insulating material often consists of fibres with air between them. So the diagram shows a section through some insulating material. So we've got the cold loft here, then this is the warm room, and then here we've got this insulating material which is made up of air trapped between fibres. Then it says to explain how this type of insulation reduces energy loss by conduction. Now, conduction happens mainly in solids where the heat is passed as vibrations from particle to particle. Now, it happens best in metals because they have free electrons that can pass the vibrations on, and they can travel along much, much faster than the vibration would travel through the material as a wave. So there's a few things to think about here. Firstly, I've already said conduction happens mainly in solids, but we've got air trapped between the fibres. So air is a poor conductor. So we can get right for our 2 marks that air is a poor conductor because it is not a solid. And then we can also say that the fibres are also poor conductors because they are insulators. They wouldn't have the free electrons to pass the energy on like a metal would. The next part of the question asks you to explain how this type of insulation reduces energy loss by convection. Now, we know that convection happens when you have a fluid, either a liquid or a gas, and energy is given to an area of that system. It causes that area of the fluid to heat up, become less dense, and then rise. Now, I've just been talking about movement there. And the question stated very clearly that the air, which is a fluid and could take part in convection, is trapped. So it can't move. So if you can't have any movement, you can't get convection. There's 2 marks, so we need to make that point by saying that convection currents, and that's the key word here, because currents, thinking about a flowing river, that's a current, it's a flow, cannot occur if the air cannot move. So we've got 1 mark for mentioning that word current, and a 2nd mark for saying that it cannot move because it is trapped.